Okay, so consider this contingency table, the same one. So whenever you have a contingency table like this, so then we'll be having the total. So you can just add a total here. So here the total is 30 and the total is 60 here. And the total of A is so 10 plus 20 is 30 here, and complement of A total is 60. So you will, the total sample size is 90. All right. So now what is the conditional probability of A? So given B occurred, so this is the conditional probability of A, given B has occurred. So anyone? Yes, Wei Yang has given. So B has taken place. So we have to look. Okay, the sample space here will be 30. Okay, for B. So because B has occurred, and now you're looking for probability of A. So probability of A, okay, the event is 10. So we can write this as 10 over 30. Okay, so you can write this as 0.33. Okay, next the B. So what is the probability of A? So given the B complement has occurred. So the B complement has occurred means your sample space will be 60. That's correct. So B complement has occurred means the sample space for B complement is 60. Then what is the probability of A complement? So probability of A complement is, you can see, is 20. So here you can write, so 20 over 60. So that can be 1 over 3 or the same thing. So you may get 0.33. All right, so this is probability of A given that the B complement has occurred. Okay, so next probability of A complement, okay, given B complement has occurred. Okay, so B complement has occurred means again we'll be looking at this number. Okay, then probability of A complement. So A complement is okay, for B complement, so this is 40. So for part C, we can write the probability of A complement given B complement has occurred is 40 over 60. Okay, so this can be 2 over 3. So you can write this as 0.67, round it off. So this is part C. Is that clear? Guys, let me know if you have any questions. Anyone got any questions? All right. Then can you answer part D? So are events A and B are independent? Yeah, they are not independent because, so we can write probability of A complement, conditional probability of A given B occurred is not equal to probability, is equal to probability of A. Okay, so these two are equal. So events A and B are not independent. So you can write for part C like this. So since the conditional probability of A given B occurred is equal to probability of A, so A and B are not independent. Is that clear? Guys, any questions? Let me know. I think we'll do this again. So the two events independent means, okay. I think we'll be doing in the next question. I clear this, then we'll go back to the next another question. Okay, look at this question. So here again, the question is related to the Generation X and the boomers. The data is the same data. So you have Generation X and boomers. So the sample of Generation X is 1,000 and also boomers 1,000. So this is about, again, about paying the full amount each month. So Generation X and boomers. Now the questions are different here. So the first question is related to if a respondent is selected is a member of Generation X. Okay, so what is the probability that he or she pays the full amount each month? So this is about the conditional probability. Okay, so probability of pays full amount given that he is from Generation X. So the respondent selected is a member of Generation X. So that means we are looking at Generation X. Okay, so and what is the probability that he or she pays the full amount each month? So we know that the event has occurred is Generation X. Okay, so now you are asked to find out the probability of who pays the full amount each month from Generation X. So what will be your answer for this? So Generation X is known. So now you need to look the probability of full amount paid. Yeah, so the answer is simple, right? Yeah, 440 over 1,000. So for part A, the answer will be, so we need to just take 450 from Generation X Okay, who paid the full amount every month? Out of generation X, the total sample space is 1000. So the answer will be 440 over 1000. Now, can you answer the next one? So if you choose a respondent selected is a boomer, so this is again the conditional probability. So you are looking at the boomers. So there are 1000 boomers. Okay. Now, what is the probability that he or she pays the full amount each month? So out of the boomers, how many of them will pay full amount? That's correct, Denise. So the amount who pays the full among the boomers is 630. So the probability for B will be, the conditional probability for B is, so 630 over 1000. So that is, yeah, 63%. All right. So that is for part B. Next, part C. So each payment each month is independent of the generation. So you have to link generation and paying full payment. Is the probability of one is dependent on the probability of other? Okay, for part C, I clear this. Then I stop.